Okay, so good day to everyone. I am your teacher Anna, and today we will going to discuss our new topic, which is solving linear systems of equations in word problem applications. Okay, so let's have first our definition. So for our definition, we have solving linear systems of equation in word problem application. It involves the finding the values of unknown variable by simultaneously solving multiple linear equation. Okay, that represent relationships between these variables in real world scenarios. Okay, so this process enables the precise demonstration of solution to practical problems by algebraically analyzing and interpreting the given information within the context of the word problem. Okay, so let's try some examples. But before we go to our examples, first we have this focus to this topic. Okay, so our first topic is the polynomials module. Next is the points of investigation, and lastly our conjecture or the conclusion in our lesson for today. Okay, so now let's jump to our examples. So our first example, the coffee shop sells two types of coffee blends: home blends for $5 per pound and premium blend for $7 per pound. The shopkeeper wants to create a 20-pound blend that costs only $6.50 per pound. Now the question is, how many pounds of each blend should be used? Okay, so to understand the application in this our example, let's look our paper. Okay, so this is how it should be solved. Okay, so for our example number 1, we let the X be the pounds of house blend, then Y will be the pounds of the premium blend. Okay, so our equation will be, we have X plus Y is equals to 20, and we have 5X plus 7Y equals to 6.50 rather, times 20. Okay, so for our solution, we have to solve the system equation, right? So from X plus Y is equals to 20, we get the X equals to 20 minus Y. Okay, it's so obvious how we came up this equation. So we subtract both sides with Y. Okay, so next is substituting X in the second equation. So how it happens? To substitute the X, okay, to substitute our X to the second equation, we will get, so this is our second equation, so we have to substitute this value of X. So 5X plus 7Y is, we will get 5, the value of X, which is 20 minus Y, so plus 7Y. Okay, so let's just simply simplify this equation. So again, we should not forget the 6.50 times 20. 6.50 times 20, we will get 130. Okay, now let's try to solve or simplify this equation. By solving this equation, we will get 100 minus 5y plus 7. 5 times 20, 5 times negative y or minus y. Okay, and then let's bring down the 130. Okay, next we'll get 2y, this one. So we'll get 2y equal 30. So divide both sides by 2, cancel. So our y is 15. Now, let's substitute the value of y back into the x. Okay, so this is our x equation. So let's substitute it back. So let's be here. Okay, so our equation is x is equals to 20 minus y. X is equals to 20. The value of our y is 15. Okay, so let's have 15 there and simplify again. 20 minus 15 is 5. So the solution in our example number 1 is 5 is the pounds of house blend. Okay, and our 15 is the pounds for the premium blend. Okay, so let's have our second example. Okay, so now let's try this example number 2. So for our example number 2, it says that a train travels from the city A to city B at the 50 mph. Okay, while the car travels from city B to city A at 60 mph. Now, the distance between the cities is 300 miles. If they start at the same time, how long will it take for them to meet? Okay, so let's look at the paper. Okay, so for our second example, distance, speed, and time problem. Okay, so as per our given, let t be the time taken to meet. Okay, and then our equation, our given equation will be 50 t, which represent as time, plus 60 t is equals to 300. Okay, so to solve this equation, let's just simplify this. Okay, so 50 plus 60, we're going to have 100, t equal 30. Okay, so to let t alone, so we have to divide it by 110. This is 110. We have to divide it 1 to 110. Okay, so this cancel out. T is equals to 300 over 110. Okay, so to make it into its lowest term, think of a number that both of this denominator and numerator will be divisible. So as 300 and 110, we can have the 10. Okay, so let's divide it by 10. So 30 divided 10 will have 300 divided 10 will have 30, and the 110 divided 10 will have 11. Okay, so as simple as that, the time taken for the train and car to meet is 30/11 hours. Okay, so now let's proceed to our polynomials module. Okay, so for our polynomial modules, we have 5 steps. Okay, so first step is to understand the problem and identify the unknown. Okay, second step is to write down the equation based on the given information. Of course, it is very important. The third one is to choose the method to solve this system of equations. We can use the substitutions, eliminations, or matrices, and other way to solve the given system of equation. So the fourth step is to solve the equation to find the values of the unknown. Okay, and lastly is to check if the solution satisfies all the original equations. So let's have example for this. Okay, so for our polynomial modules, as following the steps. Okay, so let's have some example. Okay, so following polynomial equation, let's try f of x is equals to 3x cube minus 7x squared plus 5x minus 2. So we can perform various operations in this polynomial, such as finding the roots, evaluating the polynomial at the specific point, and determining the degree of the polynomial. So let's start by finding the roots of the polynomial equation. Okay, so finding the roots. Okay, so let's try finding the roots with this example. So to find the roots of this polynomial equation, we can use the methods like factoring, synthetic division, or numerical methods like Newton's method. Okay, so like use the synthesis division method to find the roots of this equation. First, we have to identify the possible roots using the rational root theorem. Second, perform synthetic division to find the roots. Okay, so synthetic division is possible, or it is the possible roots of the polynomial equation are the factors of the constant term divided by the factors of the leading coefficient. And in this case, the factors of the constant term is the -2 or positive -1, and it is also a positive -2. And the factors of this leading coefficient is, this is the leading coefficient, which is 3, and can also be a positive -1 or a positive -3. Okay, so let's perform the synthetic division to find the roots. Okay, so again, our given is 3x cubed minus 7x squared plus 5x minus 2. So let's assume the root to be x is equals to 1, and let's perform the synthetic division. Okay, so x is equals to 1. So to perform, we'll have f of 1 is equals to 0, because this remain 0 is the remaining. Therefore, x. Okay, so let's try this first. How we end up with this? Okay, so 1, 3 minus 7, and 5 minus 2. Okay, so let's just have to simplify this, and then we'll get this, which is 0 is the remainder. Therefore, x is equals to 1, is the root of this polynomial equation. Now, we can factorize the polynomial equation as, okay, we can factorize this as f of x is equals to x minus 1 and 3x squared minus 4x plus 2. Okay? So, the detail of this solution, or let's try to summarize this one. So, our x is equals to 1 is the root of the polynomial equation. Then, factored form of the polynomial equation is the x minus 1 and 3x squared minus 4x plus 2. Okay, so this example for our polynomial module is an example of how we can work with polynomials. Find the roots using the synthetic division method rather. And now let's jump into the points of the investigations followed by our conjecture rather. Now, for the points of our investigation, we have the point 1 that it explores, okay? In this topic, we explore different types of world problems involving the linear systems, such as what we have examples earlier, okay? The mixture problems and the distance, time, and the speed. Next is the point 2. We experiment with varying numbers of equations and unknowns to understand the complexity of the solving linear systems. And our point number 3 is to investigate. It helps to investigate the real world scenarios where linear systems are used to model and solve the practical problems. And our last point of investigation is it analyzes the efficiency of different solution methods and compare their effectiveness in the various contexts. And to the last part of this session, the conjecture. Okay, so in the conjecture of this topic is in the real world scenarios. Okay, so in real world scenarios where linear systems of equations are used to model relationship between variables, the solution to the system represents a point of intersections that satisfies all the equations and corresponds to the meaningful solution in the context of the problem. Okay, so thank you for listening for this video, and I hope you learned something. Have a great one.